Hello, everyone. Mick Prince and Wayne Hartle from DCEO, and with us today for this webinar is Paul Knight. I think everybody in the network is familiar with Paul, and his bird Stash will be in the background occasionally. But anyway, without further ado, Paul, you want to go through some of the significant changes for the 2021 standards?
Sure. Thanks, Mick. Thanks, Wayne. So as you know, every 3 years, we update our standards. About a year ago, DOE updated the SWS, the Standard Work Specifications. So a lot of the work this year was making sure that our standards were in compliance with the SWS. And most of the changes that you'll see in the standards are related to that. And there are footnotes in the standards giving you the specific location in the SWS where that change is from. So I think you all have received a copy of the electronic copy of the standards PDF format. I just wanted to point out something very quickly to you, that on the left, you've got this little bookmark tag. So if you select that, you can see the different sections in the standards. And if you click architectural standards, that opens up to all the various sections. And let's go look at wall insulation. You select that, and you've got the different sections here. And we want to go look at dense pack, for example. You select that, and then it takes you right to that page for the wall insulation information. And then you can collapse it. We'll look at something else if you want. It's a very easy way of maneuvering around the PDF and getting to exactly what you're looking for without wasting a lot of time.
Hey,
everything.
Paul, we are planning on printing the standards as well, but until the U of I gets those printed and shipped out to the LAAs, we've just got the electronic version. I did get a question a week or so ago on when we were going to get hard copy. We're working on it.
My understanding is that they're at the printer,
okay,
but I don't know when they're coming back.
More to come on that.
Yes. So, as in the past, rather than having everyone thumb through the standards trying to figure out what's new, we've put together a list of significant changes. And I wanted to walk through those significant changes, beginning with the diagnostic section. So these aren't all the changes, but ones that we thought would be of interest to the network. Beginning with the house setup for the blower door, we wanted to define what winter and as found means. So when we do a blower door test, we want to make sure the house is in the winter condition, meaning that the windows would be closed. As found means that the way you find the house, if you find holes in the thermal boundary, like a broken window, a hole in the ceiling, that's an as found condition, and the assessor should do the blower door test in that as found condition. Modified the language for basements to talk about crawl spaces, that oftentimes the crawl space is within the thermal boundary of the home. That is, we are going to insulate and air seal the foundation walls. However, the hatch from the house to the crawl space should remain closed during that blower door test, as a crawl space is non-occupiable.
Makes sense to me.
We deleted a good chunk of the ASHRAE information. We put this in there years ago when ASHRAE was new to everyone. We think everyone understands ASHRAE now. So we took it out of the standards. If you want detailed information on it, you'll find it in the assessment manual. Likewise, on the zone pressures, we cleaned up a lot of that language. I think most people know what zone pressures are, so we took that out of the standards. More information can be found in the assessment manual. The pressure pad test. This is primarily for ducts that are in a vented crawl space. When the assessor is at the home and finds a vented crawl space with ducts in them, and the assessor decides that the foundation wall will be the thermal boundary, the crawl space will become conditioned space. And we don't do pressure pan tests on ducts in conditioned space. So if the assessor is thinking ahead, there's no reason to do a pressure pan test on ducts in vented crawl spaces if the assessor is going to change that thermal boundary.
Same, Paul, in a finished attic situation where they might take the thermal boundary down the roof rafters and then make that outer ceiling joist now conditioned.
That's correct. And this is not to say that if you're in a crawl space or in that knee wall cavity that you just talked about, Mick, or even in the basement, if you find an obvious disconnect, you're going to fix it. But you don't need crawling around. You don't need to be crawling around in a crawl space looking for duct leaks if you're going to make the foundation wall your thermal boundary.
Got it.
We cleaned up the pressure pan. Oops. We cleaned up the pressure pan procedures. Just a lot of information in there that I think just confused the issue. So a lot of that information we took out. We did highlight clear the baseline. Mick, can you see the little hand moving around there?
I can see it.
All right. Okay. We changed the name of this duct-induced room pressure test to room-to-room pressure test. We felt duct-induced was just too confusing. People used to think I'd made that name up. But so we just cleaned it up as a room-to-room pressure test. It is not a required test, but can certainly be helpful when trying to solve a spillage problem, comfort problem, even an indoor air quality problem.
And that's just a pretty simple test where you're just measuring pressure differences between rooms, right, Paul? So
The blower door is off. The only thing that's running is the air handler, and you're measuring the pressure difference from the room to the hallway or the main body part of the home.
yeah,
Very
I'll show my H here. You'd have that on the A channel, just measuring pressure.
Yes, just
But
measuring the pressure difference from the room to the main body part of the house. That pressure difference should be no more than 3 pascals. And it's really important where you have central returns that is supply only in the rooms. So when someone closes that bedroom door, how does the air get from that room back to the return grill, usually out in the hallway someplace?
right, I'm assuming that there could be performance issues in those homes where the return air can't get back.
Right, performance issue and comfort issues. If client complains that their bedroom is too hot or during the summer or too cold during the winter, well, if air can't get out of the room, air has trouble getting into it. So it could be a comfort issue as well.
Right. All right.
Section 1161 exhaust fan flow meter procedures. We took out all the language on how to set this thing up. I think people have been doing this for a number of years. We don't need to tell them in the standards how to do it. Procedure still in the assessment manual, but we simply deleted all of that language. Spillage test out. This is for architectural contractors. And made 2 changes here. One, we added this comment that contractor shows up at a house and the house is already pretty tight, that being 2,500 CFM or less, the first thing they ought to do is a spillage test. Make sure that the water heater is not spilling before they do any air sealing work. If they don't do this, and they air seal during the day, and at the end of the day, they do their spillage test out, and the water heater's spilling. Well, maybe it was spilling before they even started their work. So as you know, this test doesn't take long to do, and we're just recommending that it be done in tight homes before any air sealing work gets done. And then in the standards, I think the language was of how to do the test was like in a paragraph, but we just broke it out step by step to make it a little easier to follow.
Paul, we had a
Yeah.
question last week, and it was basically like, this is redundant. They're doing the worst case depressurization. Why are they doing that? Well, and I explained that this test is modified for the architectural contractors, and it's not the same as setting the house up in worst case, et cetera. And so
It is.
when
You're absolutely right. There's two major changes, differences. This one, we are assuming worst case. When the assessors and final inspectors do it, we actually find the worst case. Here it's being assumed. And second,
and so
go ahead.
I was just going to say, Paul, when we're checking spillage at an assessment or a final, then they are setting the house up in worst case and doing a spillage test. And
Right.
go ahead. The
So
second
yeah.
change, sorry.
So here they're assuming it. Assessors, final inspectors actually find what it is. The second thing is that the spillage test out, contractors don't use a manometer. They just assume the house is in worst case, fire the water heater, check for spillage, they're done. When the assessors and final inspectors do it, they're using a manometer to actually identify what the worst case is before they check spillage. Those are two major differences.
So yeah, no, it's crystal clear to me, but you could have a contractor that did the test exactly the way it's prescribed here, did not have a spillage problem, and then the final inspector does come out and puts it in worst case with a manometer and sees that there's a spillage problem.
Absolutely. Absolutely. Yes.
Doesn't mean your contractor didn't do the test.
Right. That's correct. Yeah.
Different setup potentially.
Okay. And there's really no change for the time limits where spillage has to cease, so that remains the same. So I'm going to move on to the architectural significant changes. We added a couple of new sections right up front regarding insulation. The SWS has flame spread and smoke development numbers that the installations being used in our homes have to meet. And the table there, pretty much all the same. Flame spreads have to be less than 25 for bachelor blown, foam board, spray foam less than 75, smoke is all less than 450. And what the flame spread is simply, it's a measurement of how fast a flame moves, I think, over 10-minute exposure. And during the same exposure, they monitor how much smoke is developed. Essentially, anything with a flame spread under 25 and under 50 is really good. So all our installations have to meet these flame spread and smoke development numbers. And our concern was, well, the installations that we're using, do they meet these numbers? So let me jump to the end very quickly here. We put together a little table of insulation manufacturers and their insulation types with the flame and smoke numbers. So anything in black meets the requirements. In red, it would not meet the requirement. So you may want to check with your contractors the type of insulation that they're using. Have them check with the manufacturer to make sure that the flame spread and smoke development meet our guidelines.
It's best to not catch it on fire. That's
That's the goal.
yeah.
That is the goal.
Looks like the issue is mostly with foil-faced bats and craft.
Well, I was a little surprised that foil face would be at 75. You think the foil would offer some protection.
Hmm.
Craft face bats aren't rated because it's paper.
Right.
Burns really fast. So if you are using craft face bats, and we do use them on occasion, you know, they have to be protected. And we'll get into that in just a minute here. Okay. We have a new section for contractor requirements, 2012. And basically, the contractors have to provide documentation of the insulation used, attics, sidewalls, foundations, floors, rim joists. And we broke out the different insulation types. We got loose fill, dense pack, bats, foam board, spray foam, and rim joist. And for each of those, we just list the requirements, the documentation the contractors have to do at the home, and leave that documentation in a location that can, it will be easily found by the homeowner.
Paul, this is basically the same as our attic certificates that we've been doing for years, only it encompasses any insulation product.
That's correct. Yes.
We've had a few people ask, where are we supposed to put this? You know, if it could be taped to the furnace, maybe by the electrical panel, if it's in a closet or somewhere down
Right.
in the basement, something like that, just
Yeah.
somewhere
Yeah.
that the client can find it and
Yeah.
it can be inspected.
Yeah.
I'm going to throw Craig under the bus, Craig Buchanan. He told me he was going to develop a form for everybody to use for that, but I haven't seen it yet, Paul. So
Okay.
more to come on that.
There's another new section in here, section 202, ignition and thermal barriers. This is primarily where we use spray foam. Spray foam on foundation walls, spray foam on the back of knee walls, spray foam on basement walls. Not so much spray foam on rim joists. This doesn't really apply to that. Depending on the location where that spray foam is being used, excluding rim joists, we need to install an ignition or a thermal barrier. If the space is really not used very often, like a crawl space, it has to be protected from fire with an ignition barrier. If it's in the basement, where people go in and out of space fairly often, you need something that's a little bit more robust, and that would be thermal barrier. There's a wonderful document, it's noted there, SPFA 126, that spells out where thermal and ignition barriers are required and the types of materials that would encompass a thermal or ignition barrier. I know some agencies are using this intumescent paint coating. They just spray it over the spray foam, and that works as an ignition barrier. So you may want to follow up with your contractors, and particularly with this document, to see what's required and where it's required. We've always had this requirement in our standards, but DOE seems to be making a stronger point about this. So we're also emphasizing it here.
Hey, Paul, why is the rim joist excluded from this?
The code says you can get up to 3 inches of spray foam before it has to be covered with an ignition barrier.
Okay.
So in most cases, we're not going more than 2 inches, so that can be definitely exposed.
And that's in a rim joist only where you can have up to 3 inches.
Yes, rim joist, basement or crawl space. That's
So
correct.
it's like basically it's a de minimis area and thickness.
Yeah. Right.
Okay.
We added a new bypass. This is one of Mick's favorites. If you have our whole house fan, DOE wants that covered with an air barrier as well as insulated up to R20. We've been having some discussions about how to make this happen because DOE specific is supposed to be in the attic and not from the inside of the ceiling. So we've been talking about how to make this happen.
I still don't know how to make it happen, Paul, where we don't have to get into the attic to remove it, based on the season of the year. If it's in the spring, I can only imagine a 90-year-old client of ours going up into the attic and walking across ceiling joists to remove this. So
Right.
Doesn't sound very realistic.
I still think that it's something we should try to address from inside
I agree.
the
I
home.
agree. Yeah.
And I certainly, if somebody has a suggestion or they can provide a detail on how the contractor is getting that done, I'd love to see it. So,
Yeah. I think we'll have more information coming on this one.
right.
We
For
modified
now,
our language. Well, go ahead.
I was going to say for now, we're doing the best we can.
That's right. Modified our language for spray foams so that we can use it inside the living space, underneath counters and cabinets, in locations where it's not going to be visible to the clients on a daily basis. And also modified our language about installing drywall boxes around recessed lights, particularly where the roof pitch doesn't provide sufficient clearance. You normally want to take that box 4 inches higher than the finished level of the insulation, but sometimes it can't happen. We don't want to cover the box with any insulation. We don't want to cover with gypsum board if there's less than 3-inch clearance between the top of the fixture and the gypsum board. So we have to let the heat dissipate through those non-IC rated lights. And again, this is primarily an issue where you don't have the clearance between the top of the box and the roof sheathing. Knob and tube wiring. Our standards said we wanted to maintain a 1-inch clearance between insulation and knob and tube. DOE said it has to be 3 inches. And my guess, we were probably already doing 3 inches. So I don't think that's a big change. Okay, top plates, insulation baffles. We're going back 6 years, I guess, when we wanted insulation baffles placed in every rafter cavity where there was soffit venting. We changed that about 6 years ago. 1 baffle for every 3 rafter cavities. DOE says no, you need 1 for every rafter cavity. So we've gone full circle on this one.
Just giving them what they want, Paul.
Yeah. Regarding attic hatches, sometimes the only access is through a gable vent, which is fine for a contractor insulating the attic. It makes it difficult, though, for an inspection and even if the client wants to get up there. So if that's the case, we're asking that an interior access hatch be cut through the ceiling. Oops. Okay. So this is one example here on a knee wall where we're using spray foam behind the knee wall. the interior finish, your gypsum board or drywall provides protection from the inside, but we need to provide protection from the outside of that, from the knee wall cavity. So if there's really nothing going on back there, we just need an ignition barrier. If the client's using it for storage or even some occupancy, we need a thermal barrier. You'll see language like that throughout the standards where there's any reference to spray foam insulation.
So generally, Paul, there's not much going on back there, so it would just need the ignition barrier, the intumescent paint or whatever we're using
Yeah.
for that.
That would probably be the easiest. Yes.
That stuff can be rolled on, or of course, if you've got, it's really viscous stuff, so you'd need a really heavy duty paint spray it on.
Yeah, I've heard people spraying it on. On attic venting, we deleted a lot of sections on attic venting. Basically, the sections describe what the attic vents were, but since we're doing very little venting, just got rid of all of it. Crawl space insulation, we clarified the language. The thermal boundary of a crawl space in site-built homes can either be the foundation walls or the floor above the crawl space. Pretty straightforward. In a mobile home, the floor is always a thermal boundary. Once again, pretty straightforward. Question came up when you have manufactured homes put over a foundation. So it's technically like a mobile home, but then it's also like site built. So we're treating that as a manufactured home on a permanent foundation. It becomes like a site built home where the thermal boundary can either be the foundation wall or the floor above it.
So, Paul, if we were looking at insulating one of those, we could weigh the options of getting in and dense pack or insulating the floor. I say dense pack. I don't know if we necessarily hit dense pack level, or we could just address the wall, the foundation wall.
Correct.
I would always pick the foundation wall if I were the installer, but there is an option there to do it either way.
Right.
That's what I'm saying, right?
It's just like a site built home at this point. You have the option of the foundation wall or the floor.
Okay. Crystal clear.
Okay. While we're still in the crawl space, the contractor needs to put a sign in 8.5 by 11, warning the client that they shouldn't store hazardous or flammable materials down there, that you don't want to damage the ground vapor retarder. In case of damage, that should be repaired. So this should be somewhere right near the access opening to the crawl space. One change that DOE made that we didn't adopt, that they're going full circle, and that's what's in this box. They're saying in crawl spaces that you can use fibrous insulation as long as it's non-absorbent, like fiberglass. So they would say, years ago we used to use fiberglass bats in crawl spaces, and DOE said, no, you can't do that a number of years ago, so we stopped doing it. Now they're saying it's okay, but we're going to stay the course and not use fiberglass insulation in crawl spaces.
Yeah, and if you don't get the air sealing perfect and you've got a cold air behind that insulation, it's getting wet back there, and I think a lot of people have probably pulled an old bat out of a box sill or the foundation wall is wet behind there. So
Yep, no, that does happen. Yeah,
seems like a building durability issue.
yeah. Spray foam insulation, we made the distinction between air sealing and insulating foundation walls. So we can air seal foundation walls, and that would be 1 inch of spray foam. If we're insulating them, we need at least 2 inches. And one thing you may want to check in your catalogs is that for spray foam insulation, we use an R value of 7 per inch. So if you're calling for 2 inches spray foam on a foundation wall, your catalog should say R14. I've seen some that are at 12, maybe 10. So we're not getting all the energy savings if you have the wrong R value.
Paul, I see there's a note there too. This measure is not acceptable for poured concrete foundations. We've
Yes.
a lot of people over the years just spraying the 1 inch, calling it air sealing, and it's like you're air sealing something that doesn't even allow air to move through.
Right. Good point. The poured concrete foundations are pretty tight. But if you're looking at a brick, stone, even concrete block foundation, they can be pretty leaky.
Right.
And then one change with respect to window and door replacements, it's really a budget issue, that if they're approved as an air sealing measure, you have to use HHS or state funds. You cannot use DOE dollars for that.
Yeah, and this goes back a couple years, Paul. We created that air sealing policy, 250 CFM reduction, then you could replace it as air sealing.
Right.
DOE told us they really liked that we had a policy like that. And then, I don't know, a year or so ago, they put out guidance basically stating that the only time you can replace a window or door is when you get an SIR above 1. And so we liked having that flexibility to install a window if it was really in bad shape and leaking a lot. So we just said we'll do it with HHS instead.
And then we saw this table earlier with our flame spread and smoke development numbers. We'll move on to the mechanical section. We just clarified our language for combustion air, just following what the SWS had. I think it's a little cleaner than what we had, but really no major change there. We just deleted all references to fuel oil systems. I don't think we run across these anymore. So if you're looking for information on fuel oil systems, you're not going to find them in the new standards. So you may want to refer back to our 2018 standards. Combustion safety testing, we added a little clarification about checking for spillage where the furnace and water heater share a common vent. What we do, we check for spillage at the water heater first. But then if you have a common vent, as shown in that image there, you leave the water heater running, and then you have to fire the furnace. And hopefully the flue gases go up. But if this is undersized, or if there's partial blockage in there, some of these gases will spill back to the water heater. And this wasn't real clear in our earlier standard. So any have a common vent like this, or even to the furnace and the water heater going into a chimney, you need to check spillage twice, once just with the water heater, and the second time with both the water heater and the furnace operating. For worst case depressurization, we have a number of exceptions we're doing the worst case depressurization. And we clarified this. All the vent, you don't have to do the worst case depressurization if all the combustion appliances are sealed combustion or power vented, as long as there are no wood stoves or fireplaces in the house. So it says if you're doing a final inspection and you put in a 90+ furnace and a power vented water heater, you don't have to do the worst case depressurization. Nothing's going to spill.
Saving time, Paul.
Trying to. We have a section on furnace operation standards and improvement. We've made a comment about the total or external static pressure. There's a whole section on that, and we'll get to that in a few minutes. Talking about duct leakage sites, we make another reference to total external static pressure. We'll get to that in a few seconds as well. Duct sealing materials. Basically, we're still using mastic and fiberglass mesh, but clarified when they're to be used. So, leaks.
No tape, Paul. We still can't do it.
Still gonna do tape. You're correct. So, essentially anything 1/4 inch or more, you're gonna need the fiberglass mesh and the mastic. Yeah. You can use mastic if the holes are less than 1/8 of an inch. That is no tape, just mastic. If you're no more than 10 feet from the air handler, there's our static pressure again. Essentially, you're going to be using the fiberglass mesh and the mastic for all your duct sealing. If you get larger than 3/4 inch, we need a sheet metal patch, and then the mastic.
If you've got contractor complaints, have them call Paul Knight.
And I'll see, there's all your, just refer them to the SWS. So get all the information right there. We added a section about heat pumps. Essentially, if we're using heat pumps in Illinois, we are going to need some type of backup heat. We're in a heating-dominated climate. At some point, the heat pump's just not going to be able to provide all the heat that we want. So there has to be some type of backup heat source or auxiliary heat. And this could be electric resistance baseboard or electric resistance strips added to the air handler. And you know, the cost of doing that should get rolled into the cost of doing the heat pump. You cannot use the existing furnace as your auxiliary heat source unless you have a thermostat that only turns that furnace on when the heat pump can't meet the heating load of the house. Did I get that right, Mick? Sound about right?
I don't know, Paul. I feel like we've installed a lot of heat pumps over the years, and if it wasn't working and providing enough heat, we surely would have had a lot of client complaints.
Okay.
This is new, and it's something we've got to do. And so maybe you just install 1 or 2 baseboard heaters in the
Right.
house along with the heat pump, and
Just in case.
those would be operated manually by the client.
Yeah.
When they got cold, they could go hit the thermostat for those baseboard heaters, I guess.
Yeah.
This is mostly in mini splits.
I would say mini splits would definitely, they don't have a electric furnace, so to speak, so you would definitely need something like that for a mini split.
We have a new section on condensate removal. for furnaces. This all comes directly from the SWS. Oh, draining it to proper locations, correct pitch, doing the condensate line in accordance with the manufacturer's specifications, applicable codes. I suspect we're doing most of this anyways, but you may want to just review this with your contractor and make sure that we're all on the same page with it. Brand new section, total external static pressure. We're putting in a lot of new furnaces with ECM motors. And these, let me start off by saying there's really two types of ECM motors. There's a variable speed and a single speed. The single speed is an EEM motor or an X13. That would be the single speed, and then the ECM, we have the variable speed. The problem with the variable speed ECM is that it ramps up. If it sees, it knows it's supposed to deliver a certain CFM to the house. And if there's a lot of pressure in the duct system, that variable speed motor is going to ramp up to make sure that that CFM is getting into the house. The problem is once it ramps up, we're losing the energy savings. The X13 motor, that's an ECM motor as well, but it's single speed. It'll ramp up a little bit if it sees high pressure in the system, but we'll still get some energy savings from that motor. So as a guide to the assessor, they measure total external static pressure. That could guide their decision as to, well, we can put in a variable speed ECM motor in here because we've got low total external static pressure. Or, well, we better go with the X13 because we got some high total external static pressure. We are going to have training on how to do this, refreshers on it. But the idea behind all this was to give the assessor an idea as to what type of furnace and fan motor should go into this house, whether it's a variable speed ECM or a single speed X13 ECM motor. Yeah, go ahead.
I was just going to say, in addition to it ramping up and not getting the energy savings, when that ECM variable speed motor ramps up and it's operating under too high a static pressure, it also shortens the life of the motor itself.
That's correct. Yes.
And obviously that's an expensive fix. We don't want our clients to be put in a position where a few years after they get a new furnace, they got to put in a new blower motor. So
right.
I'm an X13 believer.
Okay. We also put guidance in here that if you have some very high total external static pressure, way of breaking it down to figure out where the problem is. Now, we're not saying that assessors should be doing this all the time, but if you really want to break it down to figure out where the problem is, or maybe as a final inspection, or even the heating contractor, and try to resolve the problem, we have guidance in here on how to do that. Heating system replacement standards. The only change here is our boilers are now supposed to be 95% efficient. We added some language from the SWS about a water heater replacement. If you have water heater in garages, you have to be at least 18 inches off the floor. Make sure we put them on a level working surface. We've got space around them where we can do some work, get in and out for inspection, maintenance items.
Hey, Paul, what's the 18 inches off the floor? I don't, why is that?
I think it's a combustion thing. I'm not exactly sure. That's in code. It's in the code. But that's a good Richard White question. It has to do with something I'm guessing with combustion issues.
Okay. Good enough for me.
Okay. A lot more language on our water heater replacement. One thing that was new to me, maybe not new to everybody else, was that we need a separate water cutoff, both the hot and cold water lines. Added some additional information about the heat pump water heaters. We want to make sure we have enough air for the manufacturer's specifications, for that heat pump water heater to work correctly, and installed in such a location where it's not going to affect the indoor thermostat reading. And these things are taking heat from the house to heat the water. Good thing during the summer, not necessarily a good thing during the winter.
Paul, I think they have heat pump water heaters that draw the air from outside and expel the air outside. I've seen those in the past. That's probably not what most people are.
No, that would be a good thing. Yeah. You wouldn't have this problem. And just a little information on the tankless water heaters, for clearance issues, and make sure it's sized properly so that when the clients want hot water and there's multiple users, that everybody is happy with the amount of hot water that they're getting. There are no significant changes to the mobile home section. Go over to health and safety. We've added some efficiency ratings for our exhaust fans. Efficacy has to be at least 2.8 CFM per watt. I suspect a lot of our fans are already at this. You simply take the rated CFM divided by the wattage. It has to be 2.8 or greater. Kitchen exhaust fans, same efficiency rating. 3 zones on the kitchen exhaust fans. So they've got that, I think it's Air King makes that kitchen exhaust fan that I think it's less than a zone. Down at the training center, Paul Francisco has used it in training. And I was trying to show that fan to some contractors and how quiet it was. I turned the thing on and I thought there was something wrong with it because I couldn't hear anything until we put some smoke underneath it. So I was very impressed with how quiet that thing is.
Paul, is the maximum 3 zones is when it's in high speed?
I want to say yes. Or maybe you're just changing out kitchen exhaust fan to a new kitchen exhaust fan, not trying to meet the actual ventilation requirement. It still has to be no more than 3 zones. I mean, Paul's thing with this Air King model is that you can use that Air King to meet your ASHRAE requirement. That's how quiet it is. It's adjustable. And I don't remember what the maximum rating on that is, Mick, when you do crank it up to its maximum rating.
Okay.
Okay, so exhaust fan ducts extending through non-conditioned spaces, supposed to have their joints sealed. We just clarified with what. And here we could use tape. That's okay. Dryer vents extending through unconditioned spaces. It used to be, had to be insulated at R3, now it's R8. And then just clarify some language on smoke detectors as well as the C-hole. I think that's pretty much it.
Paul, on the CO alarms, they don't have to be plug-in anymore. That's a big change, right?
Yes.
Of course, right here at the end, it's getting feedback on this.
So, any questions, comments, suggestions on the standard? Please get them to Mick, Wayne, or myself. You know, we don't like to, but I guess we can make changes midstream if something's not right or we find a better way of doing things.
Agreed. All right, Paul, I'm getting this feedback. Let's end this thing.
Okay. It's a pleasure.
All right.
Talk to you guys later.
Thank you, Paul.
Thanks, everyone.